Lesson, we're going to put together everything we've learned about rational expressions and talk about how we can simplify complex rational expressions. And so I'm going to show you two different methods that you can use. You can choose the method that you like best. In the first method, we're basically just going to use order of operations and simplify it one piece at a time. So that means I would start by doing the subtraction in the numerator. X over 6 minus 3 over x. I need a common denominator. So I'm going to multiply the first fraction by x over x, and I'll multiply the second one by 6 over 6. And that gives me x squared over 6x minus 18 over 6x, or x squared minus 18 over 6x. Okay, so that's the numerator. And then I would do the denominator, 1/3 plus 1 over x. Again, I need a common denominator. First term I multiply by x. Second one I multiply by 3. So let's see, that gives me x over 3x plus 3 over 3x. So x plus 3 over 3x. And then I'm going to finish by doing this division problem. So here's my numerator divided by my denominator. So x squared minus 18 over 6x divided by x plus 3 over 3x. To divide, we copy down the first, change to multiplication, and flip the second one. So x plus 3, there we go. And then I would look for common factors. Unfortunately, 18 is not a perfect square, so I cannot factor the x squared minus 18. That means I can only cancel this x, and I can cancel a 3 out of the top and the bottom. 6 divided by 3 is 2. And so then I am left with x squared minus 18 all over 2 times x plus 3. And that's my final answer. So that's the first method. Basically, we just use everything we've already learned, do it one step at a time, and then divide at the end of the problem. Now there is a second method I want to show you, and you can definitely choose the method you like best. I don't care which method you use. So if you just want to focus on the first method, that's perfectly fine. But this second method I think is a little bit faster in some cases. So the idea is you look at all of the denominators. We've got a 6, an x, a 3, and an x. And you find the LCD for all of those denominators. In this case, it would be 6x. And then you take the expression, and I'm just going to copy it down so it's a little bit bigger. And we are going to multiply everything by that least common denominator. So I'm going to take every term on the top and multiply it by 6x. And every term on the bottom, and multiply it by 6x. And if I do this correctly, I should be able to actually cancel out my denominators. So in this first term, the 6's cancel, and we're just left with x times x, or x squared. Second term, now it's the x's that cancel. 3 times 6 is 18. On the bottom, 3 goes into 6 2 times. So I've got a 2x, and then the x's cancel, plus 6. And then you should check and see if there's any common factors, but we can't factor that x squared minus 18. We could take a 2 out of the 2x plus 6. Either way, there's nothing we can cancel, and so either of those answers would be correct. Notice it's the exact same answer we got before, just using a different method. So let's try using method 2 on example 2. The only denominators I see in this problem are the x's. And so that means I am just going to multiply everything by x. Everything on the top and everything on the bottom by x. So x times x is x squared, and then we get a minus 2x. And then this last term, 1 over x times x over 1, the x's cancel and you're just left with a plus 1. Something similar happens on the bottom. We get an x squared minus 5x. And then again, that last term, 4 over x times x over 1. The x's cancel, and you're just left with a plus 4. And then finally, we do have to check and see if we can simplify. The numerator, I think we can factor this because 1 times 1 is 1. And if they're both negative, adds up to -2. And then on the denominator, 4 and 1 is 4. And if they're both negative, that does add up to -5. We can then cancel the x minus 1's out. And my final answer is x minus 1 over x minus 4. All right, let's do 2 more. And again, I really am going to focus on the second method. If you like the first method, that's fine. But this second method is really going to help us in our lesson 15. Okay, so example 3, my denominators are y and x, y and x. So my LCD would just be x times y, or y times x. So I'm going to multiply every single term by that. So let's see, first term, y's cancel, and I get x squared. Then the x's cancel, so minus y squared. And then on the bottom, I just have an x, and then plus y. Once again, we should check and see if we can factor. The numerator is a difference of perfect squares. I can factor that as x plus y, x minus y. Oh, and that means we can cancel out the x plus y's. And all we're left with in this problem is x minus y. And that's my final answer here. Okay, last one. So my denominators are x plus 2 and 2. And that x on the bottom is technically an x over 1. So our only denominators are the x plus 2 and the 2. So that means my LCD is going to be 2 times x plus 2. So I'm going to copy down the problem, multiply everything by that LCD. Okay, so everything gets multiplied by 2x plus 2, 2x plus 2, 2x plus 2. All right. So in the numerator, first fraction, the x plus 2's cancel, and we're just left with the 2. Second fraction, now only the 2's cancel, and we are left with the minus, and I'm going to leave this x plus 2 in parentheses, because this minus right here is going to apply to everything in the parentheses. And then I'm going to rewrite the denominator as 2x, x plus 2. Just like in previous sections, I do usually leave denominators in factored form, and I multiply out or simplify numerators. So let's do that. In the numerator, we can distribute that minus. So we get 2 minus x minus 2 over 2x, x plus 2. And then 2 minus 2 is just 0. So that means I'm left with a negative x on top, 2x, x plus 2. And then finally, I think there's one more thing we can do to simplify. We've got a common factor of x. So if we cancel those x's out, we're left with a negative 1 on the top and a 2x plus 2 on the bottom. And I'm going to leave my answer like that. Once again, I like to leave the denominators in factored form. That's because that allows me to see if I can cancel things out. But if you want to distribute the 2, you can. It definitely will not be marked as wrong. So that's it for this lesson. Let me know if you have any questions.